In this lesson, we're going to talk about square roots. Uh, so first of all, what is a square root? Yeah, this should be a review for you more than anything, but it's worthwhile talking about. So a square root is basically just the root of some squared number. Now, a squared number is any number to the exponent of 2. So 1 squared is 1. The square root of 1 is 1. Similarly, 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, and the square root of 9 is 3. You could just easily say 7 squared is 49, so the square root of 49 is going to be 7. And you could do this for any number. Now, why is a number called, or why is anything to the power of 2 called squared? Well, just as a quick review, if we had a square area here that had equal length, so any square has equal length and width, this one I made up to have a length and a width of 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Now, if you remember a little bit of geometry, if I was looking for the area of this object here, of this square, I would know that the area of any rectangular object is equal to the length times the width. So in this case, the area would be equal to 5 times 5. So 5 units by 5 units. And that, of course, will give us 25. And if we counted all of the boxes in here, we would find out that we had exactly 25 boxes. So that's why we call any number, so 5 to the power of 2, 5 squared. And, as I was just explaining, this symbol here is used to find the root of some square. So in this case, the square of 5 is 25, right here. So the 25 right there. So the square root of 25 is going to be equal to 5. Just in the same way, I'll make that cut out so it's not involved with either of these, but that's basically all the square root of 25 means. So really quickly, let's go through all of the square roots from 1 to 10, and then I'll give you a few extras as well. So, as we already said, the square root of 1 is 1. The square root of 2, the square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. And the square root of 81 is 9. Now, one thing you may have noticed is as these numbers go up in a regular sequence, so 1, 2, 3, 4, 5, 6, 7, 8, 9, these ones go up in what we call an exponential sequence. So 1 goes to 4, which is a bit of a jump, but not huge. And then it goes to 9, which is again a little bit bigger, then to 16, which is a bigger jump. 25 is a bigger jump. And 36, 49, 64, and 81. So you can see the gap between 64 and 81 is obviously much bigger than the gap between 1 and 4. So just remember that that's sort of how it works in the future. Now, to find the square roots of larger numbers, basically, you start with 100. So the square root of 100 is 10. And then it really follows the same pattern as these, just with some extra zeros. So the square root of 400 is 20. Now, let me use a different color here for a second. You'll notice that this number here, 1 and 1, is the same as the square root of 1 being 1. The square root of 4 is 2. So that's all the same. What changes is that whenever you're finding the root of something, if it has 2 zeros on the end, that just drops down to 1 0. 400 drops down to 20. So you can continue, basically you can continue to make the exact same pattern here. So the square root of 900 is going to be 30. Square root of 1600 is going to be 40. And so forth, down to really 8,100 would be 90. So that allows you to find the square roots of quite a large number of different values. But we're not always going to have what are called perfect squares. So all of these numbers here are what are considered perfect squares. So they can always go down to a whole number. Sometimes you'll be given the square root of a non-perfect square. So for example, if I was given if I was asked to find the square root of 21, how would I go about doing that? Well, first of all, we think about what we do know. So we do know that we can find the square root of, I'll do it over here, the square root of 16, which is a little bit smaller than 21, and we know that we can find the square root of 25, which is a little bit larger than 21. So the square root of 16, of course, is 4, and the square root of 25 is 5. So we know that whatever the square root of 21 is, it has to be somewhere between 4 and 5. From there, we can start using some trial and error. Remember how I said that that the values go up exponentially, so that when you're at the smaller numbers, there's only a small jump as the numbers get larger, whereas once you get to the higher end, they go much faster. But from there, you can sort of just start experimenting with different decimals between 4 and 5, because we know 4 and 5, if you had that on a number line, has many numbers in between it. So right in the middle here, you would have 4.5. Here you have 4.25, and so forth. Up here, you might have, say, right there, maybe 4.8, something like that. So looking at this, 21 is kind of in between the two, maybe a little bit higher than exactly in between 16 and 25. So you might be inclined to think that it's somewhere up in this side. However, remember how I explained that the square roots go up in an exponential way, so they get bigger faster. So it may actually be lower than you initially think. So maybe if we started out with 4.5 and just doing our math and saying, well, what is 4.5 times, do it this way, times 4.5? Well, doing your long mathematic, 5 times 5 is 25. 4 times 5 is 20. Carry the 2, 22. And then, of course, we have the 0. 4 times 5, 20. The 2. 4 times 4 is 16, plus the 2 is 18. And we would have 5, 2, 10, carry the 1, 2. So we've got 2025 and we have 2 decimal places up here, so 20.25, which, as you'd notice, is a number between 25 and 16. It's also a little bit smaller than 21, but still we can say that's pretty close. That's a pretty close number. So we can guess 4.5 is very close to the square root of 21. It's not exact, but that's fine. And if we do have a number that is close to, but not exactly a number, there's a symbol that we use. So normally we would say equal to, but in our case, we're going to use a slightly different symbol. It's the same. It looks sort of the same, except it's a wavy line rather than a straight line. So basically it means approximately equal to 4.5. And at the grade 8 level, that's a perfectly acceptable answer for this. Obviously, mathematicians and computers and various things can get to a much more precise number, but 4.5 is a pretty accurate number. Now, you can also, of course, use your calculator to find out what these numbers are. So in the case of the square root of 21, what you might type in, it's a little bit different on different types of calculators, but on some calculators, what you might type is, there's the square root button, so I'll do that as a button, and then you would type 21, so 2, 1, and then of course the equals button. Or in other ones, you would actually type it as 21, and then the square root button, and then the equal sign, of course, and that'll give you an answer. So it depends on which one. Actually, sometimes you don't even have to press the equal sign here. As soon as you press the square root, it'll give you the square root of 21. So play around with your calculator, and especially with a number that you know. So you could use 16 or 25, something like that, and see if it gets you the answer that you're expecting. If we were looking for the square root of 21, we would find out that it is actually equal to, so square root of 21, the actual value of it, 21, is 4.58257, and my number just keeps going on. So it's not an exact number, but that's an approximation. But if we said it's about 4.5, that's pretty accurate. I mean, we could have said 4.6, but 4.5 is just fine for grade 8 mathematics. So I hope this helps you complete the worksheet. Some of them you can try doing without using a calculator, and then maybe check your answers using a calculator. It's important to know how to do it without a calculator, just so you know that your calculator value is actually accurate and you did it properly. So try using both techniques. Thanks.